I will continue with electrolysis with other examples on electrolysis. I will take two examples about acids, electrolysis of acids, solutions, concentrated and diluted, and of base solutions, also concentrated and diluted. Let's start with acids. Concentrated acids. Hydrochloric acid, concentrated hydrochloric acid. I will not draw the electrolysis cell each time. This time I will just concentrated acid, so not necessary that the ions of water that will be oxidized and reduced. So I will just compare. At the cathode, I have H plus and H plus, the same ion from water and from the acid. And by the way, you know that H plus is acidic, so in the acids I have to find H plus. So the only option I have is the reduction of hydrogen to give hydrogen gas. I will just cross this out. At the anode, I have the Cl minus and the OH minus. Since I have the halide, then the halide is the one that will be reduced. So I will have chlorine gas. The leftover as the water. I will take the same example, hydrochloric acid, but diluted. Remember that I will have the same types of ions, but at the cathode, okay, I have both H plus. As I said before, for this example, I don't have any other option for the cathode reaction, which is the hydrogen gas. But at the anode, remember that in diluted solution, the ions or the number of ions of the electrolyte are not effective or are not enough to be involved in the reaction, so only the water ions that will be involved in reaction. So only the hydroxide ion is the ion that will be involved in the reaction and will be oxidized. So I will have oxygen gas. So the leftover here is HCl, as I just did not put any acid in this solution, as if it's only water. Another example. H2SO4. Concentrated. Because it's concentrated, so I have a lot of ions of the electrolyte, so they may be involved in reaction. Let's see. I only have the hydrogen. So the only option is having the hydrogen gas. I will cross away any of them. At the anode, as we said before, if there is no halide, I have to take the hydroxide ion. So SO4 minus 2 is not a halide, so I have to take the OH minus. So I will have the H2 gas and O2 gas. The leftover is the hydrogen and the SO4, which is the H2 SO4. Also, as I just didn't put any acid or any electrolyte in the solution, it will be the same if it was diluted solution, because in the diluted solution, I will just omit these two, and I will work at the cathode with the H plus, having the hydrogen gas as a product, and OH minus, having the O2 gas as a product. So as I just did the same for these two. Okay, I will take one example for bases. Concentrated, let's say MgOH2, for example. Okay, MgOH2 and H2O, Mg2 plus, OH minus, H plus, and OH minus. At the cathode, which one is more reactive? Sorry, less reactive. H plus. Less reactive, so H. At the anode, both are OH, so H plus and OH minus, the leftover as MgOH2, and if you work it for the diluted solution, you will find the same result. MgOH2 as a leftover, H2 as a product at the cathode, and O2 as a product at the anode.